This is Mr. S, and today we're doing Lesson 3, Our Population Changes in the Buffalo Related to Climate Change. So today's goal is to analyze data about the climate in the Serengeti to investigate the pattern between the buffalo population and the amount of food available to eat. Last class, as a reminder, we investigated whether the amount of food determined the buffalo population, and we did those different readings and graphed them out and found out it didn't. We didn't have enough evidence for that. And so, let's think about what stood out to you last time and what questions you still had at the end. If you take out your student activity sheet, it's going to ask you at the beginning, what did we learn last time about the buffalo's food source, and what do we still need to figure out? And then you're going to do a prediction. So if the climate is causing the changes in the buffalo population, what do you predict the graph of the rainfall would look like? So you'll draw on this and think, okay, if the climate is causing this, then what would the rainfall be doing to make that happen? Okay. So if you think that the increase in rain is causing the population to go up, you might draw a line like this. If you think maybe the rain is decreasing a lot, and that's causing the population to grow for the buffaloes, maybe like that. And then why did you draw the graph the way you did? So just explain whether you think the rain precipitation is going up or down. Don't overthink it. This is just a prediction, okay? So whether you think the climate systems are causing that. And then we're going to look at these graphs, okay? So we're thinking about what the temperature graph shows and what the precipitation graph shows. And based on this data, was there a significant change on the climate of the Serengeti from 1960 to 75? Now, a lot of students see all these dots and they say, oh, nothing's happening. It's just random dots. And that may be the case. Remember, temperature changes throughout the year. So you would have it go up and go down. You can see that there's a summer happening. So if you were to go like this, summer, winter, summer, winter, summer, winter, right? But what we're thinking about is over this time period, this is a 15-year time period, right? What is the overall trend in the temperature? And that we see with this line, okay? This line that you'll see here, that's the average. That's the trend in all of these points. And so you're thinking about what is happening with that line overall. Same with this one. These look like they're all over the place, and they sort of are, but remember that this is over different seasons and different times of year over a 15-year period. So, you get different amounts of rainfall and it goes all over the place. But if you average these things, it's this line, okay? So this is the line that we're thinking about and whether it looks significant. Is it going up? Is it going down? That's what you're thinking about here. And here you're describing what's happening overall in these situations, in these two scenarios of temperature and rainfall. And then you just conclude. What do you is this telling us much from the temperature and the annual rainfall? What are the conclusions to that? Now, one of the main ways that us scientists, can figure out what is happening in the environment and what is happening with science is to make randomized simulations. So we use computer software to simulate what's happening in the ecosystem and show us what is happening. So we're using this computer link here. So you'll go to this website and I'm going to show you to start. We have the bison in a certain area. And we're going to, I'm going to put up the speed a little bit and think about what happens to the population size over time, to the buffaloes. So if we're able to speed up time and mimic what would happen in the environment, we'll see the graph, Okay, so just pay close attention to this graph, and that will give us an idea of what we need to pay attention to. So you see that the population is growing, 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 and there's different variables that we're looking at. Okay. Okay. So you'll see now that the population went up quite a bit, and then it leveled out. And it'll go up and down a bit, but it'll stay around this area. Okay? So this is kind of what happened, right? If we have all of these variables on the same in the same area, in the same variables. So sometimes there's different variables that we're going to manipulate, but just to start, it would go up and then go down. So why do you think that is? Okay, what causes the population to grow? Why doesn't the population size level off? Start to make populations about why you think that's happening, and here is your actual prediction. You're going to sketch your prediction to the right. So how do you think the size of the population will compare at the end of your model run to what you see in the graph? Okay, so this is just a prediction. Don't overthink it, but go ahead and predict what you would see. And then we can start with investigation 1. So you'll click on this link. You're going to see the website we were just on. It's ready to go. You'll change the buffalo to 50, press setup, and then press go. Okay? And then you'll keep the model running until the time, this part, till this part, the ticks tells you that you are at least 2,000. Okay, so right now we're at 100. So you're gonna let this really play out for a while. Okay, and then you're gonna record the shape of the graph in the space below, and repeat these steps 4 through 6, changing the buffalo to add each time. Okay. And you can add more buffalo. So you're going to observe what happens as you add buffalo in each simulation. Okay, good luck. In the next video, we will wrap up this unit, this lesson.